So, yes, Mukti, can you switch on the camera?
Yes, sir.
Yeah, okay, okay. Okay, so by the way, I mean, it's great that you have achieved such a great rank. My
Thank
important
you, sir.
question is, um, what are the favorite subjects that you think you are strong at in metallurgical domain?
Physical metallurgy,
Okay,
then mechanical metallurgy,
and these are the two
thermodynamics.
subjects. Thermodynamics. Okay, okay. Acha. So, Prasanna, can you tell me? Can you draw the graph? Like you
Sorry,
have
sir.
a pen
Sorry,
and a
sir.
paper with yourself. You have a pen and a paper with yourself, right? You are having a
Hello.
pen and a paper with yourself, right? Am I not audible or what? Vishal sir, am I audible? Hello. Uh,
Yes, sir. I have.
yeah.
Now audible.
So
Yes.
can you draw the graph between entropy versus temperature? Mm, Prasanna, I guess there are some connectivity issues on your side.
Yes, sir. I have drawn.
Can you show it to me? Yes. So,
Sir,
tell me
I'm
in the graph, why does the slope of entropy versus temperature changes with time or changes with temperature? Like, why does the slope of this graph changes? Mm, I'm sorry, I don't know. Like, um, sir, is his video visible to you? Or
Yes, yes, yes. You both are visible for me and audible too.
actually, I cannot. Okay, okay, yeah. So, Prasanna, I asked you a question that why does the slope of this graph changes?
Sir, because the entropy is like enthalpy by temperature and enthalpy CPDT. So CPDT by T, as the specific heat at constant pressure increases with time, so the slope entropy increases, but uh, it will over the period the slope will decrease.
Why? No, okay, fine. Your answer is partially correct, but why at higher temperatures the slope becomes nearly constant?
Sir, because CP also increases and T also increases. Then at a higher value, there will be like it will reach the CP will become constant like 3R.
That's correct. So, but what happens at the molecular level? At the molecular level, if I'm increasing the temperature, there is increase in the, thermal vibrations among the atoms. So at higher temperature, like what is the phenomena which is taking place at the molecular level that is making CP constant?
Hmm. Can I get any hint?
Sorry, Prasanna, you are not audible.
Sir, can I get any hints?
Mm, Okay, I don't know what's happening here, but can you
Sir, is
repeat
this now
yourself?
audible?
Yeah,
And
yeah,
now
yeah, yeah,
audible, sir?
yeah, yeah, yeah.
Sir, I'm asking for a hint, sir, because I cannot actually. Um,
Actually, tell me, what is the maximum amplitude up to which the atoms can vibrate on increasing the temperature?
the cutoff distance, actually, the potential energy versus their interatomic separation curve, the cutoff distance up to which there is some force.
Yeah, right. So beyond that cutoff distance or the equilibrium bond length, the forces are mainly attractive. And if we go below that equilibrium bond length, the forces are basically repulsive. So now you tell me, does the equilibrium bond length increase if I increase the temperature?
Yes, sir.
Okay, so now like just think, try to think at the molecular level. What happens at high temperature such that the CP of my material is becoming constant?
Maybe some kind of saturation occurring, like there may be no more vibration.
No, see, vibrations are there, but you need to take into consideration, like, is this graph, first of all, you should be clear what are the different types of entropy which is present in the material. Right now, what we are talking about is the thermal entropy, right?
Yes, sir.
Now, there are other types of entropy like magnetic entropy, configurational entropy. We are not going into that depth. So, in terms of thermal entropy, see, vibrations are there. But why at that high temperature, this with at high temperature, the value of CP is becoming equivalent to 3R. And by the way, what is the name of the temperature at which the value of CP is becoming equivalent to 3R?
Mm. Is it D by temperature?
Yes, it's D by temperature. And can you write the equation of D by temperature, the mathematical equation of D by temperature?
Sir, I only know that the CP as a function of temperature A plus BT plus CT square. Maybe from that.
Okay. So see, The reason behind it is at high temperature, basically the CP is becoming constant due to, like as we are increasing the temperature, the availability of another energy modes is also there, also increases. But at a given temperature, which is known as the Debye temperature, basically there are no more available energy modes up to which a given atom can be excited. Okay. So this is
Yes.
basically equipartition theorem. You can find it in Gaskell. We are not going into the depth. Just just for your reference, I'm telling you. Okay, fine. So, Acha, tell me, what is third law of thermodynamics?
The third law of thermodynamics corresponds to that a homogeneous system will have entropy almost zero at absolute zero temperature.
Okay, 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 okay. What is second law of thermodynamics, and do you think that second law of thermodynamics basically is sorry for the background noise. Do you think that second law of thermodynamics basically is contradicting the third law of thermodynamics?
Um, Second law tells that there will be always increase in entropy. Uh,
Hmm. See,
so
according to the second law of thermodynamics, a crystalline pure material should be having a zero entropy at 0 Kelvin, right?
yes, sir.
But is it possible? The third law of thermodynamics says that zero entropy is only possible when the temperature is 0 Kelvin, right?
Yes, sir.
If a crystalline pure material is having a zero configurational entropy, and at 0 Kelvin the value of total entropy is zero, so do you think in nature is it possible to have a crystalline pure material?
No,
Or let us say, is it possible to have 100% pure material?
no, 100% pure is almost impossible, sir.
Why?
Sir, if it is 100% pure, then uh, it will be on like a kind of metastable state, because if there is slightly impurity added, then there will be huge amount of decrease in the free energy.
Correct.
So
And
it will
can you
always,
write an equation and show it to me?
sir, which equation?
Equation of configurational entropy,
Yes, sir.
and why with the addition of solutes that the configurational entropy is increasing. Can you show it to me?
Yes, sir.
Mhm.
So should I expand it to full, or just the basic expression?
Let's say in the interview you will be asked to write the equation in the blackboard, right? So
Yes,
it's
sir.
okay. Like you can, if you want, you can explain it to me also. Like you show me the equation first, and then you explain it to me.
Okay, sir. Sir, the entropy will be K ln omega. So
Mm-hmm.
omega will be the number of possible microstates. If there
Mm-hmm.
are two components,
Mm-hmm.
then the number of atoms of A represents Na and number of atoms of B represents Nb. Then the omega will be Na plus Nb factorial by Na factorial Nb factorial.
You expand it using Stirling's approximation.
Okay, sir.
Hmm. Yes.
Yes, sir, I expanded it.
Mm-hmm.
So using Sterling's expand.
Approximation.
Um,
Yes, yes.
yes, sir.
Yes, very
So
good.
the
Okay,
final
so
extraction will be,
mm-hmm. Mm. Suppose so means like without the addition of any solute element or without any impurity, I cannot produce any metal. Do you want to say this? Or all the metals, suppose we are casting all the metals, we are melting it and we are pouring it in a very, very clean mold. So is it not possible to produce any metal in which there is no impurity or there is no solute element?
sir, actually it will have very high amount of free energy. So it will be very prone to any kind of contamination. So it will be almost impossible to get 100% pure.
Acha. Now you tell me the metal volcanic eruption hota hai na? So the metal
Yes,
which
sir.
basically erupts out of a volcanic mountain, that metal is consisting of some portions of that metal is consisting of 100% pure iron. How is it possible? See, now in under volcanic eruptions means what? The molten metal which is present at the core of the earth. So the molten metal which is
Yes,
present
sir.
at the core of the earth is not having any impurity in it. So how is it possible that even if that metal is getting erupted and getting solidified and 100% pure iron is present in that metal, is it not defying the third law and the second law of thermodynamics? Acha, tell me, what are the various ways to increase the configurational entropy? One of the ways is definitely that we have added solute elements in our material. And that is one of the way to
Yes, sir.
increase the
Yes, sir.
configurational entropy. What are the other ways of increasing the configurational entropy? You think in that way. You will get your answer. मैं hint दे चुका हूँ.
Yes, sir. Sir, pure metal will not have any configurational entropy now because there is only one component.
That's what I'm saying now. Is it the only way to increase the configurational entropy to add some other impurity or to add some solute element, or there is some other way also?
Uh, Sir, if we consider vacancies, then there will be
Yes,
also.
yes, defects, right? So
Yes, sir.
you think that if that molten metal is getting erupted and it is getting solidified on the Earth's surface, then during the solidification process, vacancies might be there, and some of the vacancies might coalesce and form dislocations. Yes or no?
Yes, sir.
So
Yes,
those
sir.
dislocations are also increasing the configurational entropy of a metal. You got the answer? So
Yes, sir.
solidification defects or the accidents which is happening during solidification, even the grain boundary, that molten metal or the molten iron when it is solidifying, they are forming grain boundaries, yes or no? So if
Yes,
they're
sir.
forming grain boundaries, then those grain boundaries are what? They are a set of certain dislocations. Yes.
Yes, sir.
है ना? So the defects are also increasing the configurational entropy. So my configurational entropy is not zero for even that pure iron. You're getting it? By the way,
Yes,
what
sir.
is the crystal structure of iron which is present at the Earth's molten core?
Sir, it will be BCC because there is very high temperature. So delta
BCC
Fahrenheit.
or HCP? Because it is at high
Okay,
temperature
sir.
and
There
high
will be high
pressure
pressure
also.
also. Yes, sir. Yes, sir. Yes, sir. It will
Okay,
be
okay, okay,
HCP.
okay, 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 okay. Yeah, okay. So, Acha, can you draw the pressure versus temperature graph for that pure iron?
Yes, sir.
Draw it and show me. What happened, Mukti?
Well, actually, I'm trying to that.
Mukti, I hope you are not searching your answers on Google.
No, sir, no.
Is it too difficult, यार? मतलब चार ही तो phases होते हैं यार. Delta, gamma, alpha, and this epsilon structure. What's taking
Yes,
so
sir.
much time, boss?
Sir, actually, calculating the volume change and the so slopes.
It's okay. You draw it. We will correct it. You draw and like you draw like you as per what you interpret.
Okay.
Okay. Yeah. Acha. Uh, that you see the slope between this delta and liquid. So why the slope between delta and liquid is decreasing?
Sir, because there will be mm, with increase in pressure, there will be decrease in the boiling point.
Boiling point. Okay, so you mean to say that with that dp by dt as per the Clausius-Clapeyron equation, that
Yes,
dp
sir.
by dt will decrease, right? So why it will decrease? That's what I'm saying now. Okay, fine. If the boiling point is decreasing, that's okay. By the way, वो boiling point बोलना नहीं चाहिए, वो melting point होता है. So solid to liquid melting point होता है ना,
Yes,
boiling
sir.
point
Sir,
नहीं
sir.
होता. Right. हाँ, it's okay,
Yes,
it's
sir.
okay.
Sir, sir.
Yeah. So, but what is happening at the material level? You write the Clausius-Clapeyron equation. From there, you will get the hint what I'm asking you.
Yes, yes, sir.
Hmm.
dp by dt
So
will be delta
now
S by
you
delta
you
V.
yes, correct, right. You see at this equation. Now you tell me, if I am solidifying something, is my entropy decreasing or increasing?
Entropy will decrease.
Entropy will decrease, right? And what about molar volume? Molar volume will increase or decrease?
It will also decrease.
It will also decrease, right? So if the molar volume and both the
Yes,
entropy are decreasing, then dp by dt should be positive or negative? Mukti, did you camera? Switched off the camera. I don't know. सर आप मुक्ति का वीडियो देख सकते हैं क्या?
He left. Yeah, he joined again. Yeah, he's there.
Okay. Yeah, I can see his video again. So, acha. Okay. So, if both numerator and denominator are negative, that means dp by dt should be positive.
Yes, sir.
तो dp by dt पॉजिटिव है तो फिर आपका स्लोप नेगेटिव क्यों हो रहा है? Or is there a fundamental thing that you are missing out? Why are you living in between? Yeah.
Maybe the network issue is there, and 5 minutes is left. So
Sir, वो
he's there. He's there now.
yeah. Mukti, your video is not, I don't know.
Sir, I have my camera on, sir.
Okay, fine. Okay, fine. You switch off the camera. It's okay. I understood your point. Okay, tell me, um, in case of solid state phase transformation, what is that extra term
Yes, sir.
which governs the solidification behavior and that is absent in case of liquid to solid phase transformation?
Can you again answer?
In case of solid state phase transformation, what is that extra term which governs the solidification behavior which is absent in liquid to solid transformation? Do you know it?
Sir, sorry, sir, for the internet issue. I got disconnected again.
It's okay. Did you hear my question?
No, sir, it got disconnected in the half.
Okay. Now is my voice audible?
Yes, sir. Yes, sir.
So what is that extra term in solid state phase transformation which governs the solidification behavior and that is absent in liquid to solid phase transformation? There is an extra strain energy
The
term,
strain.
na?
Yes, sir.
Yes.
Yes, sir. Strain energy.
And why that strain energy term is absent in liquid to solid phase transformation?
Because there in case of liquid there is not defined system, because in case of when we are actually transferring from a solid state to solid state, there will be there are chance of volume expansion or contraction, so there will be generation of elastic strain in the parent phase matrix.
Acha, if there is a generation of elastic strain, then why dislocations are generated at the interface boundary? Dislocations are generated only when there is a plastic deformation, right? So in case of
Yes,
elastic
sir.
deformation, also dislocations are generated.
So the
Is my
mismatch
question
between
clear
the
to you?
two.
Yes. Do you know the concept of misfit dislocations?
No, sir.
Okay, fine. That misfit dislocations are basically those dislocations which which carry on the burden of this phase to phase volumetric changes there. So at the interface boundary, those dislocations which carry out the burden for releasing this strain energy due to the difference in lattice parameter as well as the change in the crystal structure, right? So those dislocations are known as misfit dislocations. Okay, you read
Sir,
about it. You read about misfit dislocations.
is it related to coherence system?
Yes, exactly, exactly. Okay, so the meeting is going to end, Prasanna. It was a great interviewing you, but build up more on your fundamentals, right? You know the
Yes, sir.
concepts, but you work on your fundamentals.
Sir, will you suggest which topics I should now focus on
I
before?
will do it. I will definitely do it. I will definitely do it. Now we are having other candidates in the row. I will definitely do it.